Hello, my dear champs. What's going on? How is your preparation? I hope it's good. You know me, myself Tofik, and I teach you for physics. I prepare you physics for the time. Means, let us start this beautiful class without wasting our any time, because time is valuable. Time is precious. Okay, NLM third chapter of our journey. NLM the most important. Most important because from here majority of questions will come. And here we study many things. Okay, so let us start. See, first of all, you must know one thing. Okay? What we are studying till now, it comes under kinematics. Means we will study the motion without knowing the cause of motion. Motion is straight line, motion is plane. But this Newton's laws of motion comes under dynamics, which means we will study the cause of motion. Okay, so we can say the study of cause of motion is called as dynamics, and we will start this in Newton's laws of motion. Okay, let us start this Newton's laws of motion with one beautiful word that is our inertia. Inertia. See, what do you mean by inertia? See, after eating full plate biryani, you will fall asleep on the bed. Do you feel to move? No. Who will feel to move after eating that much biryani? No one, right? Similarly, inertia means it is a property of body to resist the motion or uniform motion. So we can write inertia as inability of body to change the state of rest or uniform motion. See, try to understand this sentence as after eating full plate biryani, how you will sleep without even disturbance. Same, inertia means it is a property of any body which makes that body, if it is at rest, it will behave like it want to be at rest. If it is moving, it will like I will move for infinite. Sir, it is not possible. No, it is possible. See, I am rest. I will be in rest till the infinity. When I am moving, I will be moving till the infinity until a external force act on me and stops me. Okay, say try to understand this one. Inertia means it is the inability of body to change the rest or uniform motion. Okay, change the state of rest or uniform motion. If a body is in uniform motion, it will tries to be in uniform motion. If a body is at rest, it will tries to be in at rest only. Hope you got it. Now, see, in this we have three kinds of motion. First one, we have, see, inertia of rest. Same thing here. It is, we can say, inability to change the state of rest. Hope you got it. This is the inability to change the state of rest. For example, we can say like this case, bus is at rest. After eating biryani, my friend is sleeping. Yes, it is also inertia only. So next one we have like this case, inertia of motion. Okay, inertia of motion. Same thing. Inability of body to change its uniform motion. Hope you got it. So, for this example, you can say, see, when you are traveling in a bus, your body will be at rest. Your body will be moving. When suddenly the bus driver applies brakes, what happens? You will push forward like this. Which means what? If your body is in motion, it tries to be in motion. Okay, so I can say like this: passenger in bus while stopping. Yeah, I can say like this. Now there is a one more kind of inertia which comes under like this: inertia of rotation. Inertia of rotation or turning. So it is also same like this: inability of the body to rotate. Rotate. Okay. Inability of body to rotate. For example, see, when you are traveling in car, traveling in a car. Sir, I didn't understand. See, for example, you are comfortable traveling. If you suddenly turns the car, what happens? You will turning the car, your body will be like this. See, for example, this is our car. I am turning like this. My body will be like this. So car turns like this, but your body falls this side. Why it is happening? It is inability of body to rotate. It is called as inertia of rotation. Write down all this first. Okay, very good. Now let us study Newton's laws of motion. In that first law, say Newton's first law. I can say like this way: Newton's first law. See, Newton's first law is also called as law of inertia. So इसे हम क्या बुला सकते हैं? Law of inertia. Develop the love sense for law of inertia. Okay. Now, what do you mean by this law of inertia? Now, see, inertia means you got to know. Always remember one thing. Okay? Inertia means mass. Always remember this one. It will be very helpful. Inertia is depend on your mass. For example, if a body has more mass, it has more inertia. Okay. Now let us come to the definition of this one. See, definition of law first law is like this: every body, if a body is in uniform motion or rest, it tends to be in uniform motion or rest until or unless an external force applied on it. See, for example, you are seeing, there is one book on the table. That book will be there only till the infinity. If you apply some force and take that book, then only it will move. Or if I am standing, I will stand here only. If someone slaps me like this, then I will move. Okay, similar. I go to the example. So, when any body is at rest or uniform motion, it will tends to be in rest or uniform motion until or unless some external force act on it. So, I can write like this. What I can write? I can write like this. Okay? If a body is at rest or uniform motion, it will, one second, tends to be in rest or uniform motion. La la la, la la la, la 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 la. See, I know we have many definition. If a body is in rest or uniform motion, we tend to be in rest or uniform motion until or unless some external force act on it. Okay. Or you will, in some books you will write a body tends to be in rest or uniform motion until or unless some external force act on it. All are same. Content is very important. See, if a body is at rest or uniform motion, it will tends to be in rest or uniform motion until or unless an external force act on it. Okay. For example, you can say example like this. book on table. Yes, book on the table. We can say example. Okay, all the bodies in our universe is at rest. For example. Okay, then it will remains to be in rest until some external force act on it. Okay, good one. Now, write on this one first. Okay, fine. Your finish is also very good. Now let us discuss one main segment, which is our linear momentum. Say, remember one thing, okay? This linear momentum comes under the Newton's first law. Now, why this is important? Now, from here questions will come. Newton's first law is very simple. On that, no more questions will come. But this topic, many questions will come. See, momentum means what? See, momentum we represent by capital P. Okay, momentum is the product of mass into velocity. So simply we can say momentum is product of mass into velocity. For saying very simply, I can say momentum is product of mass into velocity. So I can write P is equals to m/v. Always remember one thing, okay? This momentum is a vector quantity. So this momentum is our vector quantity. Now you will ask, sir, if it is vector quantity, then what is the direction of this momentum? See, this momentum direction is same as the direction of velocity. So we can say direction is same as velocity. Find some momentum. Now, if you ask me SI unit, now I will say SI unit is called like this, kg meter second inverse side. Now, if you ask me dimension formula, then dimension formula will become like this, mass 1 L1 T minus 1. Okay, this is in kg system. If we can write in CGS system also, CGS system, again we will get gram centimeter second inverse, same. Okay, now it is about momentum. Okay, momentum is the product of mass into velocity, and this direction is same as that of the velocity direction. It is a vector quantity. Now, sir, it is very important. See, momentum as much as important. Now, change in momentum also important. Now, there is one more term just now. I said, okay, change in momentum. Change in momentum. Change in momentum. See, momentum मतलब कुछ नहीं है मैम. अगर एक पार्टिकल है वो इसका कुछ मास है, इट इज मूविंग द वेलोसिटी ना, तो कितने वेलोसिटी तक मूव कर सकती है, उसका मोमेंटम क्या है, क्या वो फास्ट मूव कर रही है या फिर स्लो मूव कर रही है, इसे बोलते हैं मोमेंटम. मास इनटू वेलोसिटी का टर्म है मोमेंटम. सो मोमेंटम, चेंज इन मोमेंटम व्हिच विल रिप्रेजेंट बाय लाइक दिस. होप यू गॉट इट. नाउ व्हिच इज इक्वल्स टू फाइनल मोमेंटम माइनस इनिशियल मोमेंटम. ओके, now we know one thing, okay? Final initial momentum will be mass into v initial. Say final momentum will be like this, okay? Mass into v final. A B say. Now if you ask me, sir, what is a change in momentum? I know, I'll say very simply, okay? Take bro, it is a square root of pi square plus pf square plus 2 times of pi pf cos theta. Cos theta is the angle between these two mass, and cos theta is the angle between P1 and P2. This we know. See, this cos theta is the angle between initial momentum and final momentum. This is how we calculate the momentum. Okay, right on this. We have n number of applications on this. We'll discuss that also. Okay, before that, one small correction, dude. Small correction. Just now I said, okay, momentum is equals to P final minus P initial. Okay, now, but while writing there is a small mistake. See, we'll write like this, okay? Final momentum square plus initial momentum square. Here minus 2 times of P final and P initial ka cos theta. See, where we did mistake. Now here it is a minus. Now here we have minus, but what we did now, we just added that. Kindly change that one small thing. Okay? Here the minus value will come. It won't come plus value because, okay, it is final minus initial. Okay, rate of change of final minus initial. Now then vector here is subtracting. So it will come as minus. Kindly change that one small thing. Okay. See, we thought of making 1 hour videos, but you are Gen Z kids, right? So we'll do one thing, we'll split into many videos. Fine. If you are okay with 1 hour, you can just comment me that sir, we are okay with 1 hour, we can take 1 hour classes only. So we'll meet you in next class. Till then, tata, bye bye, see you. Now next class we'll discuss about the momentum all applications. Alright, fine, bye.